Okay, so hello everyone, very good morning. So we'll wait for a couple of minutes, then we'll start. Okay. Yeah. So today, first we'll be discussing mock question. Then after that, we'll take your doubt, and then we'll continue with our week 1 to 4 summary slides. Okay. Okay. So if you have any doubt in the mock test, please ask. Yeah. We have released the solution also for mock test. Is any question, any doubt in the mock test? I'm audible, right?
Yes, sir.
Yes, sir, you are audible.
Yes.
Okay. Yeah. Thanks. Yeah. Okay. So any doubt in any activity question, practice assignment question, or graded assignment question from week 1 to 4?
Yes, sir. Sir, in activity question, sir, in activity question of 3.4, it is mentioned about that videos are stored as blob. So, what is stored as clob?
Clob, CLOB.
Yes, character large object.
Yeah. So when we stored any what is the that what is sentence videos, right?
Yes, the videos are stored as blob.
Yeah.
Then what is stored as clob? I mean, asking I am.
Actually, it means see, blob means binary large object,
Hmm.
and clob means character large object.
Yes.
So, uh, means a blob storage object is a large collection of uninterrupted binary data,
Okay.
and a clob means object is a large collection of character data. Clob is a.
Yeah. So in a PostgreSQL, Clob is not there. Instead of that, we use text data type, text text data type. If you use MySQL or Oracle, I think the Clob is there, right? In
Um,
PostgreSQL, it is a text, text. Yeah, it supports a large number of characters, up to 1 GB, yeah, storage.
so what kind of data? I mean, is that pictures?
Okay, okay. Let me give an example. Suppose you have a movie tables, right? In that you have the that movie ID and the
Mhm.
movie name and the
Yes.
movie that actual movie content, and after that's the movie review, right?
Yes.
So so for the movie ID, suppose you use the varchar or the int, hence the movie name is a similar varchar and varchar. And the for the movie contents, the actual contents, that video, so you use that blob, means by binary large object. Yeah. And for the movie review, that is the text data is a larger character set of, well, are you getting my point?
Yes,
For the
sir.
movie review,
Mm.
yeah, then you use the Clob.
Okay.
Yeah, that is for the character large. I hope
And
it is clear to you.
yes, sir. Yes, sir. So I have also one doubt that what is the use of cascade thing? I mean, on delete cascade or on update cascade? Cascade.
Okay, okay. Let me share my screen.
Mm.
My screen is visible.
Yes, sir.
Okay.
So can you zoom it a bit?
Yes, yes. Okay. Yeah. My screen is visible.
Yes, sir.
This is a instructor table. Suppose this is a department table, and this department table referencing to this. This is a reference table,
Mm.
and this is a referencing. Okay.
Relation.
Okay. On delete cascade means if we delete the parent table, suppose if you delete the biology department means this row. Suppose we delete this biology department,
Mm.
then see this row will be also be deleted. Those those department name is biology automatically will be deleted. This is called on delete cascade.
Okay.
Means if you delete the parent table, this is a parent table and this is a child table. So if you delete the biology department, so those value present in biology, this row also be deleted. If you delete the music department, and this or this this row will also be deleted. This is called on delete cascade. On delete cascade you got.
Yes, sir.
Okay. But then on update cascade.
Sir, one question in regarding this.
Yeah.
Sir, if we only delete from the child table, will it be deleted from the parent table also?
If you did not know, PostgreSQL don't allow to delete the from this tables.
Okay.
Okay. So on update cascade means if we update, suppose if we update biology, bioscience. So this value will also be updated like bioscience. This is called on update cascade. You got it? Or I will shall I example give on Postgres.
No, I understood. But I want to know that I mean updating means just changing the name.
Yeah, changing the name or anything. You can if you update in parent tables, you also be updated on the child table.
Okay. So just the reference column will change. I mean reference attribute will change.
Yeah, reference attribute.
Okay. Okay, sir. Thank you.
Okay, I would like
Well,
to the points in the there is a parent tables and the child tables. You can see the child table is a depend on the parent tables, right? So if we delete any data on the parent tables, then it will affect the child tables also. But if child table child table is the independent tables, if you delete it, it will not affect other tables. Yeah, who asked that question?
So child table being independent means it has no parent table.
No, independence means if we delete any data in the child tables, it will not affect any other tables.
Okay. So in child, if we delete in child table, it won't affect the parent table.
Yes. Because parent table is not dependent on that
Child
child
table.
table. Yeah.
Hmm.
So PPA 2 question 2.
Can you sell up?
Week 2, practice 7 question 2, right?
Practice, yes sir, yes sir.
Okay.
Okay, let me check. Okay, let me copy this. This candidate Q1, right?
Yes sir.
Okay. Let me share my screen. This one, right?
Yes sir, this one.
Ah, suppose, uh, okay. Suppose you have the following, right? A, B, C. Suppose A is a candidate key. So what is the possible numbers of the super key? You know the formula, right? If you don't know, let me explain it. Then the A is the candidate key, and AB is possible, and the AC is possible, and ABC is possible, right? So for A, you can say that the numbers of candidate key is possible. If one is A is the candidate key, then numbers of the possible super key is remaining numbers of attribute, and that is 2 to the power
2 to the
2.
power 4. 2 to the
2
power
to
2.
the power 2, that is 4, right?
Hmm.
Up to this is clear. So
Yes.
consider this one. Enrollment number as candidate key. So remaining numbers of attribute is 1, 2, 3, 4. Okay. So 2 to the power
2 to the power 4.
4. Okay. This is the numbers of possible super key if enrollment number is candidate key.
Candidate key.
Okay. Similar way, if class, section, and the roll number is the candidate key, then possible numbers of the super key is
2 to the power 2.
2 to the power 2. Okay. And the total is 20.
20.
But you have to check one case, that there is the repetition of in this particular candidate key. You can see there is a possible that class, section, and the roll number. Yeah, we include this, take the count of this, and in this also take the count of this super key twice, right? Okay, here we include this one, and this one also we include. So we need to remove that. So for that, include this as the candidate super key. Okay. and that is if we include this as a super key, then the numbers of the possible super key is 2 to the power. Only one is remaining, and that is name. So 2 to the power 1. So we need to subtract that because of the repetition.
Okay. So this step I didn't get.
This one,
2 to the power 1. How it comes 2 to the power 1.
only one is remaining. Suppose this is the repetition. You get the repetition one. This value is repeated in both the. You can take as this is set, right? A B.
Hmm.
Okay. So in this in that set, this is the intersection, right? Okay,
Hmm.
this part is the include in both the, you take the count of this particular value in this and this also.
Okay. Yes.
Suppose this is the candidate. Okay, let me. So there is a one candidate key in both the tables, and that is class section. See the possibility. And what is that? Okay. Roll. This is the one super key, one, and the second one is similar thing. This one, this one, this one, this one, and the name. Okay.
Hmm.
You can see this particular one come in the both, this one also and this one also. So we count twice there. So we need to remove that one time. Is it fine? Means
Okay.
if you remember this one, how to we count this one numbers of. Okay. Set theory, if you remember that.
Okay. Yes. Yes. Got it. Got it.
Okay.
Thank you.
Hello, sir. Good morning. Sir, I have doubt in the difference between pure set and multi-set. There was a question in which it was asking ki union is a pure set or a multi-set or both. How can we? Matlab, what is pure set and multi-set? I'm audible, na?
Yes, yes. In which one? Which week?
Sir, sir, I think in week 3 it was there. I can't find the question at this moment, but yes, it is in week 3.
Week 3 means which slide? Can you remember the slide?
Sir, wait a second, I'm searching that.
Oh,
Sir, and one more question is there in mock, question number 16.
Okay, let me. Okay, question number 16.
Question number 16, yes.
Okay, okay. So let me share my screen.
So that question is activity question 3.1, question number 6.
Okay, okay. After that, I will.
There's the multi-sets were mentioned.
Okay. Question number. Okay, this question. Hello.
Yes, sir. Yes, sir.
Okay. See, I consider the relation schema given in figure 13. If the relation employee designation and department had 6 and 5 rows respectively, what is the maximum number of rows written by the following query? Select star from employee full after join designation on employee.designation id equal to designation.designation id. Suppose see in employee and designation. So, yeah, so employee table see designation ID refers to the designation. So suppose a designation ID content designation. So designation ID content 6
6
tuple, right?
rows. Yes, sir.
Hello,
Yes, sir. Yes, sir. 6 tuples.
hello, am I audible?
Yes, sir.
So
Yes, sir. You're audible.
suppose suppose designation ID content 1 2 3 4 5 6 and the employee table contents this designation is all the ones. So what will be the full outer join? Okay, let me say, okay, let me share my parent screen.
Sir, full outer join means both the table's attribute will be there.
Yeah, so what will be the suppose designation ID content 1 2 3 4 5 6 and the employee designation ID content all the ones means 100 rows contains ones. So what will be the full outer join?
106, sir.
Oh,
Sir, 106.
yes. So that's why the maximum number of rows will be 106. Sorry, 105 will be.
Sir, the answer was given 105.
Yes, sir. 105 will be. So
How, sir?
okay.
05.
Okay, so let me share my. Okay, let me share my parent screen.
Yeah. So if you consider the same designation ID in the employee table in all the 100 tuples, and then if you perform the full outer join, so that 100 rows will get have a common designation ID between the designation table. So that will get printed, and the rest of the remaining 5 designation ID from designation table. So that will also get printed. So total 105, right? If you not consider that designation ID as a null.
Designation has 6 tuples.
Yeah, so yeah, 6 tuple, right? So if we take that, so that is unique, right? In designation table.
Yes.
Yeah, so that designation ID is a foreign key in employee table. So there must be one record for that, say D001, right?
So, sir, for being a foreign key, there must be a null key.
Must be a
Is
null
this,
key. No.
you are saying like that only, no?
If we consider all the 100 rows in as a null in the foreign key, because foreign key can have null value, right? We are not specifically mentioned that a foreign key is null there. Means it is not null there, right? In the constraint. So if we consider
Okay, sir.
that thing, though, in that case, it is 106. But ideally, there should be one, like if we, what is the concept of foreign key? Like there should be a one, means in
There
designation
should
ID,
be at least
at
a
least,
null key and repetition of tuples can occur in foreign key.
yes. Right. So if we consider all the 100 tuple as the same designation ID, in this case one, so it will, if we perform the full outer join, it will first fetch the common tuples between those two tables. So in this case, 100 like 100, and then the rest of the attribute, so rest of the column in the, sorry, rest of the tuples in the designation table. So that is 5. So 105. Yeah. Just Subhendra was presenting something. Sorry.
Sir, hello, sir.
Sir, I
Yes,
really, sir, I
yes.
really didn't understand how 105 came. See, a designation ID is a primary key in designation, and it has all the values unique. So when it
Yeah.
will be acting as a foreign key in employee table, then there also it will be unique, right?
Okay. Let me give one example. Suppose the designation ID contains 1, 2, 3, 4, 5, 6, and suppose employee table contains A and B, and the designation ID is 1, 1. So what will be the full outer join? How many tuples will be returned? Can you tell?
Sir, but it, can I?
7.
I think 8.
See,
2 and 5.
so
Yeah.
see, what will be so full outer join contains name, then designation ID. So first and then suppose the C. So what will happen? So A1, then this contains B1 and full auto content. So,
Even though
yeah.
there is a design ID is twice. It will be twice.
So which this?
From the employee tables one design ID and from the designation from the design ID. Column attribute.
Okay, so let me let's hold.
No. In the final
The
resultant
resultant.
set. Resultant.
Okay, sorry. Oh, okay. Okay, so what will be the full outer join? So first, see this contains this message with this, so one tuple, and this also message with this, so two tuples, and the full outer join contains this table also. So 3, 4, 5, 6, 7. So this contains 7 tuples.
Sir,
So
excuse me.
sorry. Mm, yeah. Yes.
Sir, can you hear me?
Yes.
Yeah, sir, but foreign key will take the values which are present in the parent table.
Yes.
But here 2, 3, 4, 5 is not present in the parent table, right?
So see, this is a parent table. So this refers to this.
Okay.
Sir,
Destination is the parent table.
we
Yes.
are select employee.designation ID and designation.designation ID equal. Then how 2, 3, 4, 5, 6 will be selected?
So see, if full auto join, what will be in full auto join? There is a then both both the both the entity sets will be there. So that's why you will be selected both.
But sir,
So
there
it
is a
fetch the common attribute, common tuple, then it will fetch the rest of the tuples from the both the tables here.
still if no, condition is not satisfied.
Yeah.
Oh, okay.
When can you stop?
Yeah.
Is it visible to you, right?
Yes, sir. Visible.
Since you know about the full outer join, right?
Yes, sir.
Suppose this is the case, then what is the numbers of the, suppose this is the numbers of tuples from the A and this is the numbers of tuples from the B and that are disjoint. Okay. Then what is the numbers of tuple?
5.
Yeah, 2 plus 5, right? Because the intersection is 0. Am I
Yes,
clear?
sir.
Okay.
Yes, sir.
Suppose this is the case. And this is the 2 and this is 5 and this is the 7. Okay. Then what is the numbers of tuple?
10.
Sir, is 5 is 5, 2
Yeah,
and
this one.
7. So I mean this is only A. 5 is only A, right?
Yeah. No. This numbers
Complete
of,
A.
okay, n A equal to 5
Okay.
and intersection B is 2
Okay, then it will be 10.
and this is 7. And how it is working? It will take this one value. Okay, this one value and after this one value, right? It is similarly working in the full outer join, right? So suppose
Okay, so in given question, how did we find intersection is 1?
Exactly. So following this
which one?
theory, in
In
the
that
question
given
of
question, sir,
mock,
activity, yeah, mocks.
Okay, let me
Intersection is
give
1, how did we find?
okay, let me give an example. This is an AB and this is an CD. Okay. 2, 3, 4, 5, 6, 7. This is the B tables and this is the A table, right? And what will be the result of if we outer join? Suppose this is the query. Select a star from A outer join B on A dot B equal to B dot C. Then what will be the output?
Nothing, 0.
It is full outer join from
In
A.
full outer join,
Yeah.
you have to see the full
So
outer
4
join.
tuples
Then
will be
4
there.
tuples will be there.
4 tuples with there. Suppose this one is 3. Then what will be your answer?
3 tuples.
Yeah.
3 tuples will be there.
Okay.
How 3 tuples came here?
Yeah.
Intersection one.
You can see the condition, right, on table. A dot B equals to B dot C there.
You will
Satisfying
get
one condition. Right?
you will get like this one. A, B, C output is like this. 1, 2, null, null. And the second one is 2,
2,
3,
3,
3, 5. And the
null.
fourth one is null.
Null.
Okay, sir. Okay, sir.
6,
Understood.
7.
Yes.
Is it clear to you, right? And similarly, you can check on the example. Suvendu, can you mute yourself? Okay. And similarly, you can check for the in the whatever given in the question number 16. So what is the case? Let me discuss it. Is it clear to you full outer join how it is work? Yeah. Am I audible?
Yes,
Right?
sir. Yes, sir. Yes, sir. Yes, sir. Clear.
And suppose we take the designation. ID and what is that name, I think. And this is the, can anyone guide me? What is the next level is there?
Employees.
Employee. Employee. Suppose employee ID is there. And that is it. And this take reference from this one. Is it so, right?
Yes.
So suppose the employee table has the following entry for the EMP ID. Okay. So it is suppose EMP ID is 1 and the designation ID is 2. And for the designation ID is, and the name is like this: 1 A, 2 B, 3 C. Then okay, can you tell me what is the output of 2 and this is 1? Let me take 2. Then what is the output for the full outer join? That is a query given in the question 16.
So 4.
4.
Sorry, not 4.
In the employee table,
So
there is
what's
credit record.
employee ID is 1 or 2?
Yeah, this is the two records for the yes. Okay. I think it will okay. Now is it clear to you? Okay. So now tell me. Yeah, similar way you can try. I given an example.
It should be
Yes,
4.
sir, understood.
4, sir.
Okay. This will get 2 times. Yeah. This is the row number 1, row number 2, and the row number 3, and the row number 4. Okay, that is 4. And what is the case for the null? This value is null.
So for 1 and 3, it will be null.
This is null. Yeah, 1 and 3 is the null for the employee side. And what is the case?
So this would return only 2, right? Because there is no common matching factor between employee and designation.
Okay, we are discuss about the full outer join. Right.
Acha, okay, 5.
Now this is 5.
Yes, sir.
And for the 106, what will be the answer?
106.
Okay, I think now it is clear to you.
Okay, so sir, I have a question. In the mock, this is the assumption that all of them have one ID in common, right?
Yes.
So that's why we got
we
105.
get the 105.
Yes, sir. But sir, in the exam, how will we know that which table is acting like a parent and which table is acting like a child? Because unless we do not know that, we do not know which table can take null values for referencing and all.
Yeah, this is a full outer joins. There is no need to require which is the parent table and which is the child table.
Yeah, so the designation table. Yes, in
yes, sir.
table, designation ID,
okay.
right?
So in an outer joint, sir, both sides can take null values, right?
Yes, Pradeep, go ahead. Yeah, sorry.
Yeah, what is your question?
No, in an outer join, the previous example that you mentioned, 1, 2, 3, 4, that A, B, C, D, both sides, right? A, B also can take null values and C, D also can take null values.
Yeah, you can check that in the PZ admin. Yeah. Okay.
And sir, in the question, it was not given.
If it creates any confusion, that can I explain in the PZ admin? So it will clear to you.
Yes.
So suppose first table is employee and let me take original example. Can anyone guide me? What is
Yes, sir. Employee has imp ID.
imp ID?
Yes, EMP ID. Written
Like
together.
this.
Yes. Yes,
Int.
sir. And imp name. Yes, int. Imp name.
Yeah.
And
Varchar.
debt ID. Yes, it is a varchar. Debt ID and designation ID. Yes, sir.
And what is next one?
Department has department ID
No,
and department name.
we only consider the designation.
Designation has designation ID, designation name, and salary.
ID.
Designation name and salary.
Now in E1. Suppose we take the null value. For the designation ID, we consider only for the null value, right?
Pradeep, designation ID is varchar.
Okay, it will work. This one, right?
Yeah.
Pradeep, it should be D1, D2, right? Designation ID.
So which one? Sir, I gives the designation ID as the null.
Okay, okay, in the employee table.
Values keyword.
Value keyword.
Oh, okay, okay.
Values.
See the table. Okay, you can see the designation is null and There is a 4 column. Then what is the original query? Select start from. Employee 1. Full outer join.
It's design ID.
Yeah, you can see here that this is for the null value if there is a 2 tuples. Similarly, you can generalize that. Is it?
Yes, sir, but this is the maximum case, right? Means the output is maximum.
Yeah, yeah. And what is the case for this common value, right?
Yeah. And in the question, it is not given that there is a common value. Then it should be 106, if I'm not wrong.
Yes, that is 106 for the maximum.
But if it is given that one common value is there, then it should be 105, right?
Here it is a foreign key, no? So it should have one common, at least one.
No, they have told that it is a foreign key, right? So at least one should be common. Na?
Yeah.
If it is nothing is common, then how it can be a foreign? Totally different, disjoint. Then how can it be foreign?
Foreign key into designation. Can I have
Yeah, so in employee table, designation ID is a foreign key, right? So there must be a one entry for the designation ID which is present in the designation table, right?
Okay, sir.
Yeah.
Yeah, so at least one. So if it is one, then only maximum case will occur.
Yeah. If you consider 2 cases, then it will match with the 2 common record, then it will result rest of the tuples, right? So if you consider D001 to D06 as a 6 tuples designation ID in the designation table, and if you consider only D001 in the employee table, it's all the 100 records, then in that case it is 105. Suppose if you consider first 50 record from D001 and next 50 record from D002, then in that case it will be 100, and then the rest of the 4, that is 104 from the designation table.
Understood, sir.
Yeah. Okay.
Okay, sir. We can discuss about that drop, delete, and the truncate. What is the difference between?
Yes, we can discuss it.
So
this table, same example you can take.
Yeah. Can anyone tell what is the difference between drop, delete, and the truncate?
So what was the question?
What is the difference between it visible to you in the screen? What is the difference between drop, delete, and the truncate?
Drops the entire table, right?
Yeah.
Delete is only for a few rows.
Okay, go ahead.
Okay, and truncate, let me guess, there must be some catch there.
Okay. Drop is the DDL command, and DDL command, what DDL command will do? Okay. Drop is
DDL command will work with tables, and delete is a DML command.
Yeah, it will manipulate the tables. Using the drop tables, we can remove the column name, and we can also remove the column that tables also and the database also. So okay.
And keys as well, right? Primary key,
Yeah,
constraints.
yeah, primary key also.
So
Let
any
me give,
database objects.
yeah. And the syntax is drop table, and what is that table name? Designation, right? This is the syntax. Yeah, it will drop the tables. If you check for this particular table in the database, so let so you can see the relation designation is does not exist because we already dropped from removed from the that database the designation. So it is a DDL command, right? I think drop is clear to you, right? Similar, we can use the drop for the remove the database also. Using the command is you can replace table with the database and the database name. Okay, and we can see it. So can anyone tell about the this delete?
Yeah, delete, as she mentioned, is a DML command. You can delete specific rows.
Okay. And what is the difference between delete and truncate?
This is what I'm trying to get at. There is a subtle difference, but I'm not able to get it.
Yeah, see, like delete will delete all. It is possible to delete all the rows using delete command, and truncate will delete all the rows, but the schema will remain. The column headers will remain. Right?
In the delete also column header will remain. Right, because the delete is the
it's
DML
not DDL.
command.
It is not changing the schema.
Yeah, yes. But truncate is a DDL command, right?
Oh,
please
okay.
Remember, please remember, the truncate is DDL command. Yeah, you can remove all the records from the tables, but without changing the that table schema. Let me give an example, right? So what is our table? This is our table, right? Suppose what is the syntax for the delete command? Anyone would
from table name.
Delete from table name. Okay, delete from table name, and we can specify the where clause also.
Yes, sir. Which rows to delete?
Yeah, where predicate. So the actual difference between the delete and the truncate is delete is a DML command and the truncate is a DDL command. And the delete command, we can filter out the row. We can delete one row also, and we can delete all the row also. You can omit this where clause also. So if you run only the delete from, let me give an example. See what. Let me insert something more in that employee tables. It will be. Now suppose you want to delete the department ID where department ID equal to D2. So what is the syntax for the query for that? DPID equal to D2, right? Okay. I have to delete, right? And now if we check, okay, we can see it's the department ID D2 is not there because it deleted that particular tuples, right? If what happen if we omit this delete this where clause, okay, so it will delete all the rows. Okay. Okay. So it is clear to you, right? Up to this delete command.
Yes, sir.
And but what truncate will do? It will remove all the records from the data. We cannot apply the where clause, and for that the syntax is truncate tables and the table name. Right. Let me insert this. And see what are the content of the table. Okay, these are the content. If we use this particular truncate command, okay, and let me see the content. You can see it remains the table structure is there, but all the records are got deleted. Okay, I think these three are clear to you: drop, delete, and the truncate.
Sir, also I think an important point to note is drop table we can roll back, but for the other two commands which are delete and truncate, we can't roll back.
In the delete command, we can roll back, right?
Yes, sir.
Yeah.
That's what I mentioned.
Yeah, you mentioned, okay. That in the delete command, we can roll back. But in the truncate, we cannot roll back because it does not store the data in the transaction log. So you can say that the truncate is pretty much faster than that delete command.
The rollback means we can get the data back.
Yeah. Yeah. Yes, you can roll. And but who asked? Aditi asked that what is the pure set and the multi-set?
Yes, sir. Yes, sir. I got it in the chat. Piyush sir has explained that. Yes, I understood.
Okay. Thank you.
Sir, I have a doubt, sir.
Okay. Go.
Sir, in not exist clause, we are checking two things, right? Whether the inner query returns an empty table or a non-empty table.
Yes.
So based on that, we are supposed to evaluate whether it will be true or false.
Yeah.
So in question number, in practice assignment 3, question number 1.
Practice assignments question number. What is the question?
Sir, that
Surendra?
one, that big question, that month of January, which department has booked halls at least once?
Okay, let me see. With 3 practice question number 1.
Practice question number.
Yeah, okay. Let me share.
Yes.
Yeah.
Yes, sir. So in this question, option number, this one is the correct option. This not exist.
Yes.
Number 2. So,
Yes.
so my doubt is that, let's say there are 10 halls in the hallmaster table.
There are 10 holes in the hallmaster table here.
Yeah. So 8001, the ID such as 8001 to 80010.
Yeah.
And in the clause where we are fetching all the January booked halls.
Yes.
So let's say we got 3 halls like 8001, 8002, and 8003.
Yes.
So in the except part, in the except clause,
Yes.
from the 10 clause, those 3 clause will be deducted,
Yes.
and we will be left with 7 clause, 7 hotels. Sorry, 7
Yes.
hotels.
Yes.
So now the department ID in HB1, that department ID, that distinct department ID, that will
Yes.
be evaluated whether the not exist is giving false or true for against that particular department ID.
Yes.
So if not exist find a non-empty set, then it will return false, right?
If it returns empty sets, then it returns true.
Yeah. So
In
non-empty
not
set
exist.
will non-empty set will return false.
Yes. Not return false.
So that particular department ID will not be there. That particular department ID will not make into the that in clause. That department ID will be dropped from the in clause, right? I mean, it will not be in the list of in clause.
Yes.
So here, then we are. I am confused, sir. So how we are checking? Because if I am checking those department ID which is not present in the January booking, so
Okay. Let me explain. See. Okay. See this subquery select HM holiday from hallmaster as HM. So question is find the names of departments that books all the halls at least once in the month of January. Means so what will return? Uh, this subquery returns list of hall ID. This subquery returns this subquery.
Yes, sir. Yes.
And this subquery returns names of hall ID if means suppose hall ID is present is 8001, 8002, 8003. Okay, and this subquery will returns means names of hall ID means at least book means once in the month of January. This already. If suppose he booked all the halls
All
in the
the
month
halls,
of.
yes.
So if ebooks all the holes. So what will be the accept means this returns non-empty sets.
Yes, non-empty set will be returned. Yes, sir.
So this will be true. Not exist means if return non. So return empty set. Sorry, this will return empty set. So this will be true. Okay, let me give
No,
one
no, no,
example.
no, no, sir. No, I think I understood, sir. Yes, sir.
Okay.
So you are telling me there are 10 halls, and I
Yeah.
have booked all 10 halls in the month of January.
Yeah. So except will return a minus b will
A
return
minus B, non-empty set. Okay, okay,
Yeah.
okay, sir. Okay. And one thing, sir, that in this case, see this department ID in the hall booking as HB1. That is the department ID in the outer clause.
Yes.
Yes,
Yes.
this one. So
Yes.
each department ID will be
Yeah.
picked
Yes.
up and
Yeah. Yeah.
checked
Yeah.
inside
Yeah.
the inner clause, right?
Yes. Yes. Right. Yes.
Okay.
Okay. Okay. Thanks.
So can you discuss question number 12 from mock?
Yeah. Sure.
Yeah, sure. Okay, let me. Let me share my screen. Is it visible to you, right?
Yes.
Okay.
This is not the question. In mock, it is consider the entity sets movie and person with a many-to-many relationship.
Yes, sir. Their watches, person, and movies are interconnected via ER diagram.
This is the question number. You mean question number 11, right?
So I'll tell you the question. It's consider the entity sets movie and person with a many-to-many relation set.
Question number 12.
The question number is different in mock solution.
That question is the ER diagram question.
This question, Pradeep, this question.
Okay, here you can see that the consider the entity set movie and the person with many-to-many relation. Subindu, can you stop sharing? This is the question, right?
Yes.
So question is, if we use wish to store the ticket numbers of that ticket purchased by a person for a movie, then in which among of the following must information will appear? So we want to store this ticket purchase. So what is your approach to do this? Please explain in three tables you have to store in one of the one of the entity set. So this question is clear to you, right? We want to store an attribute. So which is the better entity set to store that attribute? Am I clear? Okay, if you want to store in the percent tables the ticket purchase, so it is possible that the only one person is buy one ticket. He can buy many tickets. Are you able to follow me, right?
Yeah, correct. So it's a multi-valued.
Okay, and the movie also we cannot put in that ticket purchase, because the similar movie can ticket can purchase by the many people. So it is not possible in the movie table also. So we can put the ticket purchase in these watches entity set relationship, means we represent in the relation like this, watches, and the attribute are person ID and movie ID and the ticket purchase. Okay, suppose the person one ID is 1, 2, 3, and the movie ID is 3, 4, and the purchase is like that. So this particular person one purchased the movie ticket for the movie ID 2, and the numbers of ticket purchased, or the ticket purchase numbers of tickets like 4. So one may be by another movie ID with the 4, and the numbers of ticket is 5, 2. So it is possible, it is better in the watches, right?
Okay, so this is a process of elimination, right? Where can we fit the column? Can we fit it in the movie's entity or a person entity? If neither, then it goes to watches. Is that the correct logic, or
No, I use approach of this elimination methods, but you can use whatever. You got what is the question, right?
Yeah.
Yes, Charles. Say suppose you bought two tickets for the movie, say movie one and movie two, right? And I also bought it same ticket like movie one and movie two. And suppose our both the tickets get mixed. Okay, so then how we will identify that ticket is belong to me? So there must be some person ID associated with that movie ID, right?
Yeah, correct.
Yeah. So that's how we can store in the watches relationship only. If we stored in the movie ID, so we cannot identify that which ticket is yours and which ticket is mine, right? So there must be a person ID associated with a particular movie ID. Then only we can identify that.
Yeah, got it.
So that's why we are storing in the watches.
Sir. Hello, sir.
Yes.
Sir, I have one doubt, sir. While writing the group by clause, should we keep something in mind like this cannot work, or I mean, is there any situation where a group by clause will not work?
Say suppose if you are mentioning any particular attribute in the select clause, so that attribute must be either have an aggregate function or you have to mention in the group by clause. Otherwise, it will throw an error.
Okay, so let's say I have a ID and a quantity. So that quantity must be aggregated to be in the group by clause.
Yes, Pradeep, you can write, yeah. ID and quantity.
ID and quantity.
Quantity, yes.
Okay.
So
From which table?
any table.
Which table?
Any table you can take.
Okay. Product. Right. And so group by
ID.
group by ID. Okay. So and the quantity is quantity is one column is right. In
one
the product.
column, yes, sir. One column.
Product is one column. This is the ID and quantity.
Yes, sir.
So with the quantity, you have to use the either the aggregate function, and aggregate function are the max, mean, or the count, and AVJ, and the sum. You can use only with this, or if you want to reflect in the that select clause, then you have to use in the group by clause, right? And those columns, suppose there is a one this suppose name, department, yeah, product name, right? You cannot write like this. For this you have to write here the product name in the group by clause, and so either you have to do this or use the aggregate function. So whatever the aggregate function you want to use, like the sum.
So if I use the aggregate function, then I can group by I can use ID group by ID in group by or product name in group by, whichever I want.
Okay, select ID and after that
product name, I think P name.
Product name. Okay, P name.
And aggregate the sum of quantity.
Sum of quantity. Yeah. For that you group by using the ID.
Yes.
But this particular is not present in either use the group by function in that inside the group by function you can use this one, or if you want that on the select clause, then you have to mention in the group by clause. So like this.
So same goes for if I have, let's say, two ID from two tables. That like we do know we match that whether product I mean table from one ID is equal to table from another ID, and we take all the let's say attributes. Then also we have to mention both the ID in the group.
T1 ID and
T2
ID. Okay. After that
we will match with like where T1 ID equal to T2 ID, and we will select star.
Okay, select star, and you use joining, right?
Yes, yes. Normal.
Which one?
Normal, sir. For T1 comma T2.
Oh, T1 comma T2. Okay. In the where clause, or the suppose if I using the natural join or the inner join.
Okay, sir. You can do natural join also. That is no problem.
Okay. Natural join T2. After that, where?
No, sir. No, where clause is not mixed. But yes.
Group by.
Group by. Yes.
Group by.
It's a T1 ID.
T1
dot
ID. Okay. Suppose if there is not only ID, there is a B and C. So it will reflect on the star clause. It will how it will returns T1 ID and the T2 ID.
Yes, sir.
And B and C also.
Yes.
So earlier I said, if you want to display in the select clause or something want in the
Is it
this
natural
select
join, so
clause.
T2 ID will not be there, right?
This one. Okay. Please. Yeah. Thank you. This one. For the natural clause, it will.
Yeah, natural clause it will not be.
Natural join. Okay. So this B and this one C is not possible, because for that you have to use the either aggregate function or you have to add in the group by clause. So it will throw the syntax error if this is not present in the group by clause.
So the attribute which we are putting in the group by clause,
yeah.
Leaving that attribute, all the other attribute must be in the aggregate function, or they must be present in the group by clause.
Yes. You can check it out in the PG admin also.
Yes, sir. I was getting error. I was not able to understand. Why I was getting those errors. That's why I asked.
Yeah. This is the reason. For the B, you have to mention here B, or you have to avoid the B in the select clause. So you can only display whatever's in the this one, and for that is the columns aggregate function. Suppose you want to return suppose there is the department ID.
Yes.
And the numbers of candidate means employee ID is there. Suppose you group by this department ID, and you have to return the employee ID, count of employee ID.
Count of employee ID.
Then you can use the suppose this. Then use the group by function and select this department ID and the count of employee ID.
Yes. So let's say if I want to know, if I want to get a table where all the employee ID will be grouped up. All the employee table will be organized according to their department ID.
Okay.
So in that I cannot do. No, that I cannot do in a table. That will have that will have that multivariable kind of. I understand, sir.
Okay, thank you.
Thank you.
Sir, I have a doubt. In practice assignment, question number 6, practice assignment 3, question number 6, week 3.
Okay.
It is related to this concept only.
Suvendra?
Let me see.
Because according to me, all the queries are
Actually,
wrong.
yeah, in question number 6, all the queries are wrong. So actually, we'll modify.
Yeah, we also we mentioned earlier also that in question number 6, all the options are wrong. Okay, we'll update that question. Yeah.
Okay, but in solution of that particular practice assignment, you have marked that 3 queries are correct.
Yes, that we have to check. Yeah, we'll update that. Yeah.
Okay, then it's fine.
I'm sorry, which question was being talked about?
Practice assignment 3, question number 6.
Okay, thank you.
Yeah. Okay, is there any other question? Else we can move on to a summary slides here. Okay, yeah. Okay, so I think we can move on to our summary slides. Okay, yeah. So we'll start with the week one first. Yes, Anjana, you can now present.
My screen is visible, right? Am I audible?
Yes, Anjana.
Yes.
Yes, you are.
Okay. Okay, so now we will be just going through a revision for whatever we have learned in the first 4 weeks. So we'll begin with the summary of week one. So at first, we have discussed about the comparison between file handling via Python and DBMS. So there were a number of parameters which were discussed in brief details in the lecture video as well as the slides given. So yeah, so one of the parameter was that time of execution. So what it basically meant is that, say for example, we have to process a 1 GB or 2 GB file. So if by using file handling, what happens is it will take seconds to process that particular file. However, by using DBMS, if we process that same file, say 1 GB file or 2 GB file, it will take milliseconds. So what that ultimately comes up to is that the time taken to execute a particular file or data by using file handling is much more than that as compared to DBMS. Then another parameter is that arithmetic computations are easier if we are easier to be done if we use file handling via Python. We can also perform complex computations and certain types of computations. However, if we use DBMS, we will be receiving a limited set of arithmetic operations, like those complex computations won't be available in DBMS. Then one another important parameter, or you can say one important point, would be that I think all of you are pretty much aware of the fact that data is not structured, which means data is unstructured in file-based system or in file handling, right? So what it leads up to is that it leads up to redundancy in data, which also leads to inconsistency, right? So what happens is that when we have an unstructured, not predefined data, then backing up that data or recovering that data becomes a tedious job. However, in DBMS, the data is structured, so which leads to easier access. Then it also like as given that backup, recovery and restore need minimum manual intervention. So because of that structured data, it gets easier to back up, recover those data, right? So there are other parameters which if you haven't gone through it yet, we would recommend you to go through it. These are very important. You must know about the differences, I'm sorry, not the differences, the comparison between file handling via Python and DBMS, right? Okay. So the next topic was level of abstraction. So it is a 3-level model, and on the top we have on the top we have a view level, then we have logical level, and lastly we have the physical level. So here physical level provides service to logical level provides service to view level. What that basically means is that the lower levels provide service to the upper levels, right? So we'll begin with the physical level. So what it basically does is, this is the level where the data is physically present, where the entire database or the data is stored basically. Then we have logical level. So in logical level, what happens it describes how data is stored and the relationship among the data fields. Say for example, it includes the tasks such as creating a table, dropping or deleting it. Then say in logical level, we can perform the ER diagram I hope you all are aware of that theory or diagram where we discuss about the attributes, the various data types of those attributes, the relationships among them. So all those job is done in the logical level. Then finally, we have the view level. It is basically the level where data is represented. There might be a number of views for different users. Say for instance, let me take an example that in a university website, a student will have a view which will contain of his marks for a particular exam, his attendance, and his details, say his name, DOB, etc. Right? However, in the same website, for a teacher or for a professor, there might be a different view, which might consist of him entering the marks of those students and checking his salary and so on, right? So a DBA, that is a database administrator, works in the logical level. A front-end developer or an application programmer works in a view level, right? Okay, so the main thing is that these levels are primarily used in order to maintain security, simply so that the user is not completely aware of what is happening in the backend. The user is aware of what is happening in the front end, right? I hope that is clear. I hope all of you are pretty much clear about the levels of abstraction. Then finally, we had this database engine, which consists of a storage manager, query processing, and transaction management. So at first we had storage manager. Now what the responsibility of the storage manager is that it provides the interaction between the application program and the actual data that is stored on the disk or on the database. It interacts with the OS file manager, and its main job is to check the efficiency of storing, retrieving, and updating the data. Then we have query processing. So all of us are pretty much aware that if we have some data and we have to query it or to get the output, we can use this query processing. So for that, there are primarily three parts, which are parser and translator, optimizer, and evaluation engine. Now, how this particular diagram, as you can see given that figure query processing, this diagram works is that, say for example, we have a query. It can be of any language, and then when we move it to parser and translator, it will check for any syntactical error and it will translate that particular query into some relational algebra expression, right? Then what happens is that I think in week 4 all of you have gone through different relational algebra expression theories, right? So all of us are aware of it that for getting one particular result, we can have different approaches, we can have different number of relational algebra expressions which give the same output. So so there can be expressions which are more efficient or which are less efficient. So what we'll have to do is we will have to optimize. We will have to optimize the most efficient one. Then we can decide on an execution plan as to how we can access the information to get the result, right? Then we evaluate the result and check if the statistics of what we have done or what can be further improved and so on can be done. And this gets generated from the as you can see, this evaluation, the statistics gets generated from the evaluation engine, and the optimizer tries to use it. You use those statistics, right? And then finally we have the query output. So I hope you understood the basic approach of query processing. Then lastly, we have transaction management. So at first, what is transaction? So as defined, a transaction is a collection of operations that performs a single logical function in a database application. You'll be studying in depth about transaction, what are the various steps and everything in details in the week 10 and 11. We have the entire week dedicated to transaction and all. So you'll learn a lot about it. So there is this transaction management component which ensures that the database remains in a consistent state despite system failure and transaction failure. Now, what this basically means is that I hope you are aware of that theory which says that all or nothing. Like, what happens is that, say for example, we are performing a transaction, right? Say transaction 1, okay, and suddenly we are performing this transaction, and suddenly a system failure occurs, or a transaction failure, a system failure or a system crash occurs. So what this transaction hello okay, so what this transaction management component ensures is that if a system failure occurs, the entire changes that were made in that particular transaction gets undone. It gets undone. Or if the transaction is completed and after that a system failure occurs, it is well and good. It does not really matter. But if it occurs in between, then the transaction management component makes sure that the entire changes are undone and the transaction begins starts again, like after the system failure, right? Then there is this concurrency control manager which controls the interaction among the concurrent transaction. Now, what concurrent transaction means is that a number of transactions being executed or being performed at the same time. So we will be discussing about that so that there are no issues while concurrent transactions are being executed. So concurrency control manager is used for that purpose. So we will be discussing about everything in the later weeks. So yeah, so I hope you don't have any doubt in week 1. If you have, please tell. Anyone any doubt in week 1 regarding anything, any topic?
Physical level independence, logical level independence.
Okay, physical data independence, right?
Yeah.
Okay, so I would recommend all of you to please memorize, or in any way possible, please learn this drawing, this diagram in a very so that you can remember it anytime level of abstraction is called, right? So physical data independence happens here. Physical data dependence. Okay, so I'm sorry, I cannot, I don't know the name, I cannot see it. Who asked for physical data independence?
Yeah, me. My name is Madhav. Yeah.
Okay, okay. So can you tell me what does data independence mean? Like by the name, what can you get from the name data independence? What can you make up with this?
Change, like it is independent of something.
Exactly.
Whatever is there, independent of something.
Exactly. Okay. So by definition, what it means is that it means that designing the schema in such a way that changes made in the physical level will not change or will not bother the logical level, right? So implementation can be changed, but if interface changes, it might be a problem. So say for example, I'd give you a very easy, a very simple example. I hope you get cleared on this topic. So say for example, we have you have a file or a folder that consists of your personal documents, and that is stored in a in C drive. Now for some reason you have to move that particular file or folder to drive E, right? So what we can do is we can simply change the location of that particular file or folder and put it from C drive to E drive, right? So what happens is that we are simply changing the location of the file, but ultimately in the inside that particular folder, it consists of your personal document only, right? The documents are not changed, your location is changed. So that is what is physical data independence. Only the storage system is moved from one system to another, but the logical structure is not changed. Is it clear?
Yeah, got it.
Okay. Okay. Anything else? Anyone?
And ma'am, logical level independence will be from independent of view level, right?
Exactly. It will be independent from view level.
Okay.
Yeah. Anyone? Any doubt?
Yeah, okay, I think we can move on to next week 2.
Okay. Okay.
Okay, thank you, Anjana. Let me share my screen. Okay, is it visible to you, right? Am I audible?
Yes, sir.
And my screen is visible to you, right?
Yes, sir.
Yes, sir.
In the week 2, we see the summary session. In the week 2, we see only the highlight of the week 2 contents. So in the module 6, what are the highlights? You have to see the attribute type, what are the attribute type, and the schema and the instance. And you have to learn about the key, and that is the super key, candidate key, and the primary key, and the surrogate key. Okay. If you have any confusion in between any of the content of the week 2, you can stop me and ask. So this is the second. After that, we will learn about the secondary key and the alternate key. The secondary key is the candidate key other than the primary key. There is a numbers of candidate key possible. So other than the primary key, all are, we said that these are the secondary key. After that, we come to the simple key. Simple key consists of the only one attribute. Composite key, so more than one attribute that can identify each tuple in a relation. So after that, we learn about the foreign key, compound key, and the relational query. And what is the relational query? In the relational query, we take the one or two relation in that. After we perform the set of operation, and we provide a resultant relation, and that is the relational query. And the relational language, there is a procedural programming and the declarative. In the procedural programming, we specified that how to get the output of that particular query, and the declarative, we only mentions the what we needs, what exactly output we want to needs. And the program have the already knowledge about the relation of the tables and the various entity present in the database. And after that, we see the relation operator one by one. The first way, see the selection operation. Selection operation is denoted by sigma operation. Selection operation select the rows, and the projection operator selects the columns or the attribute, and which is denoted by pi. And the union operator, union, difference, and the intersection are the set operation. And for that, you have to perform this three operation, your two relation must be union or difference or intersection compatibility. And after that, the Cartesian product is used to join two relation, and a cross is this particular sign is used for to show R cross product S. And the natural joint, we read the natural joints. And the module 8 highlights is, we see the history of SQL. You can go through the slide for this particulars, and there is the DDL command. DDL command is used to manipulate the database schema, right? DDL commands, and the DML command is used to manipulate the data. Okay, and what is the basic structure of that SQL query is select followed by attribute name and the from, and after that followed by the relation involved in that particular query, and after that where clause is used for the filter purpose, right? In the module 9 we can learn about the additional basic operation, that is the Cartesian product, and the rename as operation. Suppose if you want to rename the particular attribute or a relation or the tables, so you have to mention just this as operator, and that is, suppose you have to rename instructor as I and similar way as T. This is the rename operation. And after that, the string operation is used for the pattern matching, and this particular percent, this sign is represents the 0 or more character, and underscore is represent only the single character. And the order by clause is used for sorting the whole tables using the particular columns in the ascending order or the descending order. For the ascending order, we use this particular keyword, and for the descending order we use this particular keyword. By default it is the ascending order. It will show the data in the ascending order. Second additional operator is the select top edge. It will select the top, that particular mention in the top 10. So it will returns the 10 numbers of records from the tables. So in the where clause we mention the predicate, and you pretty much familiar about this between operator. Suppose you have to find the employee whose salary range is between 50,000 to 1 lakh. So you have to use after the where clause is like where between $50,000 and 1 lakh. And the in clause is used for the, if you want to compare the particular columns or looking for the particular columns value into the set of value, means in, suppose if you want to use ID in 1 2 3 4 5, for that we use the in operator. And the duplicate operator, you have seen we use the multiset version of the relational algebra, and that is union all, intersect all, and the except all. So after that ends the week 10, we see about what are the set operation and the null values and the aggregation function. So set operation are the, you already know about the union, intersect, and the except. These are not eliminates the duplicate value. For the duplicate value we use the union all, intersect all, and except all. And the null values is signifies that that unknown value, it represents the unknown value or that value does not exist. And the aggregate function, it operates on the columns value and returns the only a single value. There are 5 aggregate function that are average, AVJ, that returns the average value, then the mean that return minimum value, and the max that returns the max value, and the sum returns the sum of value, and the count returns the numbers of value, right? Only one of these, all these 4 are ignored the null value, but for this count will return, for that's the zero, return zero value. So group by function is used to form groups using particular columns based upon a particular columns, and the having is a use if you suppose if you want to apply a condition or want to filter based upon this formed group, so then we use the having clause. And null values, as I earlier said, all the aggregate function except the count ignore the tuples that having the null values. So that's it from the week 2 contents. If you have any doubt, you can ask. Okay, Subhendu, over to you.
Okay. Thanks, Pradeep. Let me share my screen. Okay. So basically, I will be summarizing the week 3 contents. So week 3 contents begin with module 11, and we have learned various kind of SQL statement like select distinct, let's remove the all duplicate values. Then we have learned select all, then learn Cartesian product, basically Cartesian product cross product. Then we have learned how to rename as keyword. Then we have learned simple where clause and using we have learned also multiple condition like with the help of and or or. Then we have learned pattern matching with the help of like keyword. Percentage means any keywords, or this means a single keywords. And then we have learned how to adapt the output according to the particular attributes. It could be anything like ascending or descending. Then we have learned in operators. Then we have learned set operation like unions, union alls. Actually, union removes all the duplicates, but union alls returns the duplicate. Then we have learned intersect, then accept. Then we have also learned several aggregate functions like average, mean, max, count, sum. In module 12, basically we have learned subqueries, nested subqueries. So subqueries can be anything, select or from or where. So basically subquery means subquery is a query that appears inside another query statements. Subquery in the from clause also, subquery in the select clause also, and the subquery in the where. In the subquery where we can use in operators. We can also use some, any, all exist, not exist, and unique operator. Then we have seen some DML command like modification of the database, like how to delete the particular tuples or how to delete all the attributes of a tables, how to insert a data using insert command, how to update the values using update commands. In module 13, basically we have learned join expression, like in join text to relation or text to tables and return as a result another relation. Then we have learned various types of join like cross join. Basically cross join is a Cartesian product. Then inner join basically some condition. Then equation means one attribute is equal to another attributes. There are two tables, so and suppose S1 table A1 and A2, S2 tables B1s and B2. Equivalent is A1 equal to B2, like this. Then we have learned join, natural join. Natural joins, natural joins matches joins two tables based on same attributes, that name and compatible live name and compatible data types. Like suppose S1 table has A1, A2, and S2 table has A1, A3. So it will match on the A1 tables. It will implicitly, equal A1 equal to A1. Then you have learned outer join like left outer join, right outer join, and full outer join. Then we have learned self join. Self join basically it join between the same tables. Okay, then in module 13 we have also learned views. Then we will also means a view provide a mechanism to hide certain data from the view of a certain user. We have also seen why use view. Then we have also learned how to create a view using create view statements. And then we have learned also materializing view. In module 13, basically we have learned some integrated constants like not null. Not null means every in the attributes every value should be not null. Then primary key, then unique constant, then check constant. Then we have learned referential integrity and the on delete cascade, on update cascade. And in module 14, we have also learned how to create data types in SQL. There are some built-in data types in SQL also, like date, time, timestamps. Then we have also learned index creation, how to index create, and we have also learned how to user different data types. Then we have also learned domains. Then we also learned overview of authorization, like grants, some like if you want to some grants and so like to give some permissions. Suppose you can insert, you can delete, you can update, and suppose we want to tag those permissions, so we can using revoke statement we can do. And then we have seen roles, different types. We how to create roles as means suppose we want to give certain roles, so we have also seen. Then in module 40 we have seen overview of SQL function, then table evaluate functions. Then we have also learned triggers, why is trigger, what is triggers, then before triggers, after triggers, and then we have also learned trigger events like insert, deletes. What means after the insert triggers will be triggers, deletes or updates. So if you have any doubts in week 3, you can ask.
Can you explain what is like what's the function of on delete cascade, like with example? With an example?
Yeah, on delete cascade.
Yeah.
Okay. My screen is visible.
Yes,
so,
visible.
Okay, in the PostgreSQL or like this with the help of whiteboard?
Anything can work.
Okay, so if you did not understand in the whiteboard, I will tell in the PostgreSQL. Okay. Sorry. Okay. Suppose this is the instructor table and this is a department table. And this is the reference to this. Okay, this is the reference table. And this is a referencing table. Okay, and this table also called parent tables. And this also called child table. Okay, on delete cascade means if you delete certain, suppose if you delete biology or computer science, suppose if you delete biology in the parent tables. Hello, you got it? Hello, am I audible?
Yeah, audible. Yeah.
So if you delete the biology in the parent table, it will be automatically deleted. Those present in biology means this tuple will also be deleted.
Okay.
This is called is on delete cascade.
And if we delete this particular row in the child table?
Yeah, it means child table will be deleted, but parent table will not be deleted.
Okay.
And on update cascade means if we update like sometimes biology department like bioscience, if you update bioscience, so those value present in biology, it will also be updated like bioscience. This is called on update cascade.
Okay, thank you.
You got it or?
Yeah, I got it.
Okay. Piyush sir, over to you.
Sir, can you please explain about the triggers? I mean, it's constants also.
You can see there is a one tutorial Bhaskar sir.
I have watched that.
Yeah. So in the week 3 open session, we have taken one example on trigger. So on PGMN, you can refer to that.
Okay.
Okay. So first we'll take now we'll take the week 4 content. Okay, so is this visible, right?
No, sir.
No, sir.
Now?
No.
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. So in the week 2 and week 3, we discuss about the SQL part. So there is one important part in the week 2 and week 3. So that is order of execution. Okay. So order of execution of SQL command. Okay. So first from clause will execute, then where. After that, the group by clause will execute. After that, heavy clause. And then if you are using from where group by and having clause together, and after that work on that, it will based on this group by and having clause, it will select the tuples, right? And then after that, it will perform the distinct. If you are using distinct keyword, then distinct keyword will execute after the select clause. And after that, it will order by, right? So this is the order of execution in SQL command. Okay, so first from where group by having select distinct order by. Okay, so please remember this order of execution. Yeah. So in the week 4, mostly there are 3 topics. That is, first one is relational algebra part. Second one is relation calculus part. In that we have covered tuple relation calculus and domain relation calculus, right? And then ER diagram part. Okay. Now first we'll discuss about the TRC. Now see here, TR is a non-procedural query language, okay, whereas the relational algebra is a procedural query language. Okay, now TR is a non-procedural query language, and the syntax is like this. We write it as like this. Means inside the curly braces there is tuple T and there is a predicate T. Okay, so if this predicate T is true, then based on this predicate, it will fetch this particular tuple. Okay, you can see this predicate can take logical operators also and quantifiers like there exist and for all. Okay, now how to read this TRC query here? This for there exists a tuple. Sorry. So here you can see a P. Okay, it's not necessary that we have to use T only. We can use any variable. So for a tuple P, there exists H which belongs to student such that S dot CGPA greater than 8 and P dot name equals to S dot name and P dot H equals to S dot H. So what is our required condition here? That is CGPA greater than 8. Okay, so we have to specify like this. And whatever we want to find out or whatever we want to fetch, that we have to specify like this. Means for a tuple P, there exists some S belong to student such that P dot name equals to S dot name. Means it will return the name and age from a student table. Okay, having CGPA above 8. Okay, so let us take one example. Okay, so before that, we'll discuss about the DRC part also. This is domain relation calculus. Okay, so its syntax is like this. Inside the curly braces, we first mention the domain variables and then it is predicate. Okay, now if this predicate is true, then based on this predicate, it will fetch this particular domain variables. Okay, now here you can see one table, that is student table. Now let us consider this query. Okay, this TRC expression. Now here, one thing to note that we have to mention the domain variable in the same order as given in the table of the as given in the table, right? Like here you can see A, B, C, D. So okay, here we know we have the table, that is this is A, this is B, and this is C, or this is D. Okay, means the order of the domain variable must be same that in the order of the attributes. Okay, so here from this A and B we can tell that okay, A is name and B is name, so age. So from student table we are fetching name and age. So there exists A, B, C, D. So A, B, C, D belong to students table, and C greater than 75. C means marks. So marks greater than 75. So it will return the name, age of a student having marks above 75. Okay, so this is simple DRC query. Now please note this point that you have to mention the domain variables in the same order as given in the table. Okay, so if I say that it is say A, C, B, D, then this C represent the age. Okay, so that is not correct. So you have to mention in the same attribute. Okay, means in the same order. Yeah, I hope you understand this. Now let's quickly discuss one example. Yeah, so we already discussed all the three examples in the live session. Okay, so I will discuss this example. Yeah, so now here you can see there are two tables, and what you have to find out, we have to return the names of a students along with the sports. And student name from students table and sports from activity table, right? Now whose age is less than 25. So our condition is age less than 25, right? Yeah, and who have secured more marks, more than 75 marks. So our condition is age. So age less than 25 and marks greater than 75, right? And how to write this in relational algebra expression? So as you know that pi is used for a project operation, means it will project the particular attribute from the table, that is name and sport, and here you can specify the condition in the sigma operator, that is age less than 25 and marks greater than 75. And here we are joining the two tables like students. This symbol represent natural join. Okay, so we are joining these two tables, student, natural join, activity. Or either way we can write it as, instead of natural join we can simply use the cross product here, like student cross activity, but here we have to specify one condition, that is and student dot name equals to activity dot name. Okay, so it will join the table based on this condition. Okay, so this is also correct. Now its equivalent TRC query is like for a tuple T, there exists S. So S belongs to student relation and there exists A belong to activity table. Okay, now S dot name equals to A dot name. Means here you can see we have specified the condition here, S dot name equals to A dot name. So based on this condition, we will join these two tables. If you didn't mention this condition, simply it will perform the cross product. Okay, and this is our required condition, that is S dot age less than 25 and marks greater than 75. And what we have to find out, name and sports, means T dot name, here S belongs to student, right? So S dot name and T dot sport equals to A dot sports, means from activity table it will fetch the sports and from student table it will fetch the name. Okay, so this is the equivalent TRC query for this relational algebra expression. Okay, now yeah, so now about the DRC part. So in DRC, as I mentioned earlier, we have to mention the attribute in the same order. So here A, B, C, D for student. Here you can see what happened here. A, B, C, D belongs to student, and here E, F, G, H belong to activity. Okay. And yeah. So it is A, B, C, D, and this is E, F, G, H. Yeah. Then okay. So here, what is A and F here? A is the name of a student and F belong to attribute sports, right? So it will fetch name and sport. Now there exists B, C, D. So it is not necessary you have to mention the attribute, all the attribute here. If you are using this attribute here B and C, then you have to mention this. Okay, there exists B, C, D, but it's always recommended to mention all the attribute inside this there exists clause. Okay, means there exists symbol. Now there exists B, C, D. Now this A, B, C, D belong to student table. And this is the condition now. Okay, so B less than 25, B means age, and C greater than 75. And there exists E, F, G, H, which belongs to activity table. And here we have provided one condition, that is A equals to E. So means we are joining these two tables, that is student and activity table. Okay. So based on this condition, it will fetch A and F, that is student, name, and sports. Any doubt in this TRC and DRC part?
Sir, why are we using different syntaxes to represent the same thing?
Which one? In TRC?
All three: relational algebra, TRC, and DRC.
No, see, this is a mathematical expression. Okay, so it is equivalence of a SQL query. First, we write it as in relational algebra form, then we can convert it into a SQL query. Okay, simply say suppose this TRC is a non-procedural query language, right? It will only tell what data we have to fetch from the particular table. How to find out data? There is no information about that. Okay.
So is there any application of TRC and DRC?
Yes. Okay. So suppose okay, so you know how to write the SQL query, but I don't know anything about the SQL part. But I know this TRC and DRC expression. So, but I want a particular data from a table, right? But I don't know how to write a query for that. So what I will do, I will write a TRC expression or DRC expression and give it to you, and you have to convert this DRC expression in the SQL query.
Okay.
Okay. Right.
Sir, I have a doubt here. Why in DRC you didn't use F here?
F
when you are at like
F is there, no?
No, there belongs to E, G, and H. You write only. You have not mentioned the F here.
Yeah, you can mention the F also. That is no issue. But if you are, here you can also mention the A. So it's always recommended to all the mention all the attribute present in the table. Okay, because in this we are not applying any condition on this particular A domain variable. So that's why I have omitted that. But better to use all the variables.
Okay.
Okay, so there are one more example, question 1 and question 3. We also discussed in the live session. You can go through the slides. Now, so for ER diagram, you can go through the tutorials. We have 2 tutors on that, and we also provided the slide. It is a very detailed tutorial, near about 40 minutes. Please go through that. You will be able to convert the ER diagram into a relational schema. Okay. If you have any doubt in that, you can ask. And then, so these 2 slides, this is a mapping constraint here. So how to represent many-to-many relationship here? Many-to-many means 0 and here also 0 and. Okay, now there is many-to-many relationship between the instructor and student table. We are the relationship advisor. Simply here, if there is an arrow, it means 1-to-1 relationship. And similarly, you can see it is 1-to-many and many-to-one relationship. Okay, and here total and partial participation. This single line indicate the partial participation, and this double line indicate the total participation. Okay, so we have discussed this in detail in the tutorial. So this is very important slide. It is the ER diagram symbols. Okay, so we have to remember this all the symbols, how to represent the entity class. So this rectangle, this entity class is represented by a rectangle. Then weak entity class is represented by a double rectangle. Then the relationship type is represented by this ellipse. Sorry, this diamond shape. And this identifying relationship type, which is a weak relationship, it is represented by a double diamond shape. Okay. Now attribute we have to represent by using the ellipse. Okay. Then key attribute ellipse. Then underline that particular attribute. Now partial key means key associated with the weak entity set. So that we represent with the help of this dotted line inside the ellipse. And what is derived attribute here? So this attribute is derived from another attribute. Okay. So like example for age. So age is derived from the date of birth. Okay. So that is represented by a dotted ellipse. And what is multivariate attribute? Like for example, phone number is a multivariate attribute. So we represent it by a double ellipse. Okay. Now what is composite attribute here? So suppose example, there is an address. An address consists of a street name and pin code. So that is composite attribute here. So we represent like this. Okay. So please remember the symbols. Yeah. So that's it from the week 4. If you have any doubt, you can ask. Yes, anyone?
Hi, sir.
Yes.
May I know about the total participation and partial participation? How does it involve couple of multiple entities?
Multiple entities means.
Yeah, for total participation, partial participation.
Yeah.
So that is, so in this case, instructor and student, does it related to the relation advisor or does it relate to the entity? Like instructor and student are total participation, either we tell or we tell instructor is a total participation we advisor. Like this. Can you just help me understand this?
Yeah, so instructor entities, the participation of is partial participation in the relationship advisor, and total participation in student is student entity means all the attribute must be present in a relationship advisor. So just 1 minute, let me take an example. Slides. Yeah. Okay. Yeah. Okay, so just visible screen, my screen.
No, sir.
Yes, sir.
Yes, sir.
Okay. Okay. So these are the slide which I have used in the tutorial also. You can go to a tutorial. What it is. Okay. Now here you can see there is minute to one relationship between the student and the course. Okay. And here it is.
वही घंटा उठाना.
Who's that? Okay. Yeah. Yeah, here you can see the participation of a student in relationship into is total participation and it is many to one relationship. Now, how to represent this? Here you can see a student table, right? And relation, and here we are specifying the student number is a primary key here. So student number is a primary key, then student name from this attribute, and here this is the total participation of a student in the relationship enrolls. We are mentioning it as course number, right? So it is a course number, and here the course will have the course number and the course name. Understood. Who asked this question? Is any question?
Vignesh. So yeah, so just looking at the student or course, can you identify if it is a total or full participation without looking at the ER diagram?
Yeah, this double line indicates total participation. If this double line is there, means we can say that there is total participation of student in the relationship enrolls. So we have to specify the course number also in a student relationship.
Yeah, I mean, so by looking at the ER diagram, we are able to tell that student is total participation, of course, is
by looking at the ER diagram only,
by
we
looking
can say
at the
yes, go ahead, please.
Okay. So okay, without ER diagram, we won't be able to tell by looking at the entities if it is a total or partial.
No, see, first we design the ER diagram. Okay, so based on then we convert this ER diagram into a relational schema. You can go through this tutorial in detail. Okay, you can see that we have explained all the things in detail here. The slide is also provided to you in the week 4 folder. It is available.
Okay.
Yeah. Okay. Any doubt?
Sir, I have a doubt like regarding tomorrow's exam. Like, is it the paper is conceptual, or do we need to remember some of the theories also?
Like you have attended the mock test, right?
Yeah.
It will be similar. Yeah, there will be 17 questions as in the mock test. Yeah.
Okay.
Please go through the slide once. Okay.
Okay.
Okay. Yes, all the best for your quiz 1.
Thank you, sir.
All the best, everyone.
Yes. Any doubt?
Thank you.
Week 1 to 4.
Thank you and all the best. Love you.
Thank you, sir.
Best of luck, everyone.
Thank you, sir.
Yeah. Okay. Thank you then. I guess we can wind up this session.
Thank you, sir.
Thank you, sir.
All the best. How many students was there today? 50, 60. Okay.